Let's talk about the closure of a set of functional dependency. There is a concept of closure. The closure means with one or with the set of attribute, how many other attribute we can reach. Okay, I'll repeat myself. With one set of attribute, how many other attribute we can reach in one table. That is called closure. Closure will be defined with the attribute name and plus we can have as a closure. So we'll apply these inference rule that we have just seen to find out the closure. Let F be the set of functional dependency. The closure of F is the set of all the functional dependency logically implies by F. We denote the closure of F by F plus. We can find out F plus by given F by using the inference rule. So let's talk about closure. Now this is one relation. This will be denoted as one table, right? So there is a relation. Relation has all 5 attributes. A, B, C, D, E are the attribute. So you visualize that the table name is R. The column name are A. One column name is A. Another is B, C, D, E. So how many columns we have in a table? 5 columns. Here it is not listed the data. Here they are listing the functional dependency. Okay. So we have the functional dependency available. So these are the functional dependency related to a table. Now, can we determine some more functional dependency? So by applying the rule. So here we are not talking about closure. We are just seeing that with the help of those inference rule, how we can determine some more functional dependency. So these are the functional dependency which is given. Can we determine some more functional dependency? Now it says that E determine A, E determine A determine BC, A determine BC. Can we say E determine BC? E determine BC. How we can say that? With the transitivity rule. So the third rule of Armstrong inference rule, the third rule, which is A3 rule, is called transitivity rule. A determine A determine B. We can say A determine BC. So that is written. Again, CD determine E determine A. Can we say CD determine A? Yes, we can see that. CD determine A. That is using transitivity rule again. Now we have applied the decomposition rule. A determine BC. Can we apply the decomposition rule here? So it will be A determine B and A determine C. So A determine BC will become A determine B and A determine C. Then we have pseudo transitivity, which is the last additional rule of the inference rule. It says that we have B determine D and CD determine E. Can we say CB determine E? Yes, we can say that. So it will be CB determine or BC determine E. Okay. You can make B here or C here. It doesn't matter because it is in the left hand side part and both are union. B determine D, right? C D determine E. So D could be replaced with B. So CB determine E. That is with the pseudo transitivity inference rule, right? So this is the example to tell you that with the help of inference rule, how we can determine additional functional dependency. Now let's talk about the closure, how we can compute the closure. Closure of attribute set. Let R is a relation schema for the set of functional dependency F. Let X is a set of attribute. The closure of attribute set X under the set of F, and it's denoted as X plus. So any attribute set, if we want to find out the closure of it, that will be denoted as this. Let's take one example so that you can understand. So this is an example. Okay. Now in this example, as you can see, we have a relation, means a table, where we have the attribute A, B, C, D, E. How many attributes? 5 attributes are there. And we have the functional dependency, which is given here, right? What we have to find out? We have to find out the closure of A, closure of B, closure of C, closure of D, and closure of CD. Okay. Let's find out the closure. Now the first is closure of A. How we can find out the closure of A? Now, how we can denote a closure of A? We can denote closure of A with A plus. This is my closure of A. Closure means with that particular attribute or the attribute set, how many attributes we can reach with the functional dependency given. So with the A, how many attributes we can reach? So with the help of A, we can reach A. So we are putting A here. With the help of A, we can reach A, right? So A will be in the set. Now let's go and find out A is determining something. So yes, A is determining BC. So BC will also come into the list. Now B and C came. So can we find out the B is determining something? Yes, B is determining D. So D is also coming in. Now, can we find out E somewhere? So yes, with C and D, with C and D, with C and D, we can determine E. So E is also coming in. So in that way, that because we find out all the relations, so we'll not go and explore again. Means we'll not go and explore other thing because we got R here. This is equal to R, right? This is equal to R, and this is equal to your whole table. Now let's talk about the closure of B. So if I'll say closure of B, B will be here. Now we'll find out B is determining anything. Yes, B is determining D. So D is also coming in. Can we say D is determining something? So you can see D alone is not determining anything. Can we combine B and D? And can we determine something? B and D? No. So B and D also cannot determine anything else. So B and D will be your closure of B. Let's talk about C closure. So if we'll say C closure, C will be here. Now we'll see C is determining anything. Now C is not determining anything. So C is only alone in the closure. Now let's talk about D closure. D will be here because D closure we are talking about. Now can we say D is determining anything? D is determining anything? No, D is not determining anything. And the last one is CD. CD closure. Can we say CD? So C will come and D will come. Now can we say C is determining anything? C is not determining anything. Can we say D is determining anything? D alone is not determining anything. C and D is determining anything? Yes, C and D is determining E. So E is coming. Getting it? Now, E is determining anything? Yes, E is determining A. So A is coming. Now, A is determining something. A is determining B and C. C is already here. So we'll take B. So this is because further we'll go, then it will be a repeating of these attributes. So we'll not go further. This is my R. This is my R. Now, the question is, what is the significance or what is the importance of closure? So the importance of closure is to find out the candidate key. What is a candidate key? Candidate key is nothing but the set of keys or set of super key which has the property to become the primary key. Getting it? Candidate key is nothing but a set of key attribute which has the property to become the primary key is called candidate key. So closure will give you candidate keys. Now how it will give you? If the closure of any attribute is equal to R, if closure of any attribute is equal to R, then that attribute is nothing but candidate key. Now, which is a candidate key here? A is the candidate key, right? Because A closure is R. Now, what else is your candidate key? CD is your candidate key. Why? Because CD is determining, and CD closure is determining all the attribute, then it is also equal to R. Then CD is also a candidate key. Now, if we have A and CD as a candidate key, which we choose as the primary key. So the minimal candidate key will choose as the primary key. So A will become the primary key. Getting it? So with the help of a table and the set of attribute, by finding out the closure of the determinant, right? The left hand side part, we can find it out the primary key by finding out the candidate key. Is it clear? Okay, this is another example. A determine B, sorry, there is a attribute A, B, C, G, H, I are the attribute, means you have 6 attributes. These are the functional dependency given. What you have to find it out? You have to find out the closure of A, closure of B, and closure of CG. What is the closure of A? In the closure of A will come. Now, A is determining anything? Yes, A is determining B, so B is also coming. A is determining C, so C is also coming. And if B is coming, B is determining something, yes, H can be determined by B. So H is also coming. Can we determine anything else? No, we cannot determine anything else. So this is not equal to R, right? B closure. What is B closure? B is coming. B is determining H, so H is coming. What else? Can we determine? No. CG closure. CG. So CG will come. Then CG is determining H and CG is determining I. So I is coming. What else can we determine? No. So you can see here by finding out the closure of A, closure of B, and closure of C. CG means all the left hand side part or the determinant part, we find out the closure A, CG, and B. We didn't find any candidate key. We didn't find any candidate. So a table which doesn't have any primary key, that is called weak entity, right? Weak entity set, where we have to find out some alternate keys. So that is another type of study. But here, if I ask this in the examination and tell you what is the candidate key, so you will tell me that there is no candidate key. Can we have any candidate key? So if I'll put G somewhere here, if I'll put G somewhere here and G here, so AG can become the candidate key. AG, can we find out A and G and determine the all the attribute? So with the help of A and G, can we find it out? So you can see CG is determining H and CG is determining I, so we'll get I. Sorry, I also here and G also here. So AG will become the candidate key. But the what I told you, we have to find out the left hand side part, the determinant part, and find out the closure of it. We didn't find any candidate key.